In another video I have here on YouTube, we talked about population growth and population dynamics and these things called S-shaped curves and J-shaped curves. This video is going to focus on what's called demography, which is where we look at the human population. Now, with demography, as you can see with this one, we did talk about J-shaped curves, and J-shaped curves occur in populations that have unlimited resources. They don't have to worry about limiting factors, they have to worry about running out of things. But other populations have what's called an S-shaped curve, where they grow exponentially, but then they start to encounter problems. They start to have decreased food amount or water amount, which causes them to reach what's called carrying capacity, and it forms an S-shaped curve. Well, we can take this data and we put it together when we're studying humans in what's called demography. It's the study of human population size, density, distribution, birth rates, death rates, and how things move, which is migration. So when we look at human population growth, right now, the human population overall is showing unrestricted growth, which is this green thing down, the green graph down the corner, and this is what we call a J-shaped curve. As humans, we have the ability to manipulate our environment. So we can, grow food in the most unlikely places. We can clean our water. We have water treatment plants. And so therefore, we right now have unrestricted growth. Limiting factors are not bothering us. We have plenty of food, we have plenty of water, we have plenty of space, and we have plenty of mates. And again, this is because we have the ability to change our environment. We have medicines now that can basically stop natural selection. Remember, in nature, disease is one of the ways that natural selection gets rid of individuals in a population. But with vaccines and medicines, we have the ability to basically say, haha, Mother Nature, I'm going to win this war. And people are allowed to live longer. We also have the ability to make pesticides. We have the ability to grow foods, hanging from the ceilings now. So at this point in time, we are experiencing a J-shaped curve. And when we look at population growth, there's three things we have to look at. First one is what we call the birth rate, which obviously is how many of a certain individual or whatever creature that we're looking at, but we're talking about humans here, are born in an area during a certain time. Death rate, just what it says, how many people die in an area at a certain time. Immigration with an I is how many people move into an area at one time. And emigration with an E is how many people move out. So a formula you could use is something like PG plus, or PG, this is a little difficult here, PG equals B for birth rate minus D for death rate, minus because people die, they're leaving the population, plus I for immigration, which would be people coming into the population, minus E, emigration, which would be people moving out of the population. So when we look at populations, we could talk about what's called positive population growth and negative population growth. Positive population growth is when you add all these things together and you get a positive number, which means birth rates and immigration rates are higher than death rates and emigration rates. So the population is growing. You can get a negative population growth, which means that the population is shrinking because death rates and emigration rates are higher than birth rates or immigration rates. If you get a zero, all these things balance out, which is very unlikely. That means your population is not growing at all. So that's what this is talking about here with the population's growth rate. And now this just talks about the difference between birth and death. We do have to take into account immigration, people moving into an area, and emigration, people moving out of an area. Now, population's growth rate can also be affected by fertility. And fertility is basically how many offspring can a female produce during her reproductive years. And if you think about human females, most human females began their reproductive cycle in their early teens. So what's considered average used to be ages 15 and 16. Girls are starting their periods at an earlier age, and so even as early as 12 years old. But if you look at, on average, a female who begins, her ovaries turn on at about age 15, and then all the way up through menopause, which is in her 50s. basically her fertility rate, females can have one child a year, if you think about it that way. Twins and triplets are uncommon. And since our gestation period is 9 months, on average, females can give birth once a year. So if a female started her menstrual cycle at age 16 and she went through menopause at age 50, there's 34 years in between. So she has the possibility of having, theoretically, 34 kids in that time period. So when we talk about fertility rate, it's how many children could a female have in her menstrual or her ability during that time where she's able to ovulate. Now this is kind of a funky looking graph. It's what's called an age structure graph. Age structure graphs allow scientists and people studying data to look at different pieces of information at the same time. An age structure graph is divided up, as you can see in the middle, by ages. And age structure graphs are usually always drawn the same way. The left side of the age structure graph shows males, and the right side of the age structure graph shows females. So it allows you to compare boys and girls at the same age. Now this graph actually has several pieces of information at the same time. But if you'll notice down at the bottom, on average, according to this graph, if you look at children between the ages of 0 and 4, notice the males are about the same as females. So here in Queensland, Australia, there's about equal numbers of boys and girls under the ages of 4. Okay. Now, if you'll notice, there tends to be there in the middle, kind of like between the ages of 50 and ages 34, there's like a bulge. There's a large number of people born that are the same age. And then you notice as people get older, they do die at different rates. And so if you'll notice up at the top how many males make it to age 85 versus how many females make it to age 85. And so when you look at age structure graphs, it lets you see a pattern of what's going on. So notice here in France, it's what we call a stable population. The boys and girls are pretty much equal all the way up. They bulge at the same place, they decrease at the same place. And if you'll notice with a rapidly growing population, the older individuals, there's less of them. Maybe there's a war, maybe there was a famine, and not that many survived. Maybe diseases were bad. But now with modern technology, notice children are being born at a greater rate, and those children are more likely to survive to get to be an older age. Now, mobility, like we mentioned, is also affected by migration. People moving in, people moving out. And so that's something else we have to keep in mind when we look at demography.